Now we will discuss how to solve a system of linear equations using the inverse of a 2 by 2 matrix. To solve a system of linear equations using the inverse of a 2 by 2 matrix, we first have to write our system of linear equations in matrix form. That is of the form A times X equal to B. All of these are actually matrices. The A matrix composed of the coefficients of the variables here. The X matrix is a column matrix representing the variables used in the system. So in this case, it is X and Y. And the B here is also a column matrix representing the constants here. So for the given system here, if you write it in matrix form, this will be, so let's have A. A are the coefficients of the variables. So in this case, we have -2 and then 4, -3, that's the coefficient of X, and then here is the coefficient for the variable Y. And then we will write here the X, this X matrix here is a column matrix, X, Y. This is equal to the column matrix for the constants. So you have 2, 7. So this system, this matrix here represents the system of linear equation. Now to solve this, we need to compute for the values of X and Y. So to solve for X here, going back in here, to solve for X, X is just equal to A inverse times B. So that means we have to get first the inverse of matrix A. So we will get the inverse of matrix A here. So if this is your A, we have to solve first for A inverse. A inverse using the formula is just equal to 1 over the determinant of A times the matrix formed by interchanging the diagonal entries here. So we have 7, -2, and then negating the diagonal entries here. So negating -3 becomes 3. Then if you negate 4, that is -4. Now for the determinant of A, you just need to multiply the diagonals here. So we have, so let's solve here. Determinant of A is just equal to the product of the diagonal entries here, -2 times 7 minus the product of these two entries. So we have -3 times 4. -2 times 7 is -14. -3 times 4 is -12. So you have negative of -12. So you have -14 minus -12. That gives us -2. Now going back to our formula for the inverse of matrix A, we then have 1 over -2, that's the determinant of A, times the matrix 7, -4, 3, -2. Then we multiply each term of that matrix by -1/2. This is now equal to -7 over 2. -4 divided by -2 is +2. 3 divided by -2, or 3 times -1/2, is -3/2. Now -2 times -1/2 is +1. So this is your matrix A. Then next is to multiply. So again, X is computed by, or this X and Y here is just the product of the inverse of matrix A times B, or times this column matrix here. So in other words, therefore, we have xy, which is equal to A inverse times B. Our A inverse is equal to negative 7 over 2, negative 3 halves times 1, negative 3 halves and 1, times the column matrix for the constant 2, 7. So times 2, 7. Then let's multiply the matrices here. So we have, you multiply this row here by the column here. We have negative 7 over 2 times 2. So this entry here times this entry, and the 2 here times 7. And then 2 times 7, and then you add. And then here, you have negative 3 halves times 2, negative 3 halves times 2, plus the product of 1 times 7. So it is this row here times this column. This entry here times that entry, and the entry here times this entry. So we have 7, or 1 times 7. This is your B. Then you just have to simplify. So negative 7 over 2 times 2 is equal to negative 7. So negative 7 plus 14, 2 times 7 is 14. Again, this one is negative 7, and then you add 14, that gives you 7. And then here, if you multiply this 2, negative 3 halves times 2 is equal to negative 3. Negative 3 plus 1, plus 7, sorry, 1 times 7 is 7. Negative 3 plus 7 is 4. Therefore, xy, the column xy is equal to 7, 4. Therefore, that implies that, so we have xy is equal to 7, 4. This implies that x is equal to 7 and y is equal to 4. Another example, solve the following system of linear equations using the inverse. So to solve this, we will have to convert this first into its matrix form. In other words, we will write it of the form AX equal to B, where A, matrix A is the coefficient of the variables here. So your matrix A in this case is 5, 3, 7, and 4. And then the X is the variables used. So X is just the column matrix X, Y. And then B, matrix B, is the column matrix involving all the constants used. So that is 1, 2. Now, to solve this, X is just equal to A inverse times B. That means we need to compute first for the inverse of the matrix A. Let's compute for A inverse first. A inverse has the formula 1 over the determinant of A times the matrix formed by interchanging the diagonal entries here. We have 4, 5. So you just put 4 in here and 5 in here. So interchange these two. And then you negate the entries in this diagonal here. So we have negative 7, and then 3. This 3 here becomes negative 3. Okay. Now, the determinant of A it can be computed by multiplying the diagonal entries here minus the product of the diagonal entries here. So determinant of A is equal to the product of 5 and 4. So 5 times 4 minus the product of 7 and 3. So 7 times 3. 5 times 4 is 20. 7 times 3 is 21. So 20 minus 21 is equal to -1. So the determinant of A is equal to -1. And going back to our formula, therefore we have, for the inverse of the matrix, we have 1 over -1 times the matrix 4, -3, -7, 5. Now 1 over -1 is equal to -1. So we have -1 times the matrix here. So that means we're just going to negate each entry. So therefore, A inverse is equal to -4, +3, +7, and -5. And hence, to solve for the system X, which contains the variable xy, this is just equal to A inverse times B. Our A inverse is the matrix here. That's the inverse of the matrix. -4, 3, 7, -5. Now, B here is the column matrix containing the constants here. So it is the column matrix involving 1, 2. So times 1, 2. So this X here is the column matrix XY. Then we're just going to multiply the two matrices here. So to multiply this matrix by this, all you need to do is multiply the entries here by the column here. You multiply it component by component. That means -4 times 1, -4 times 1, plus the element here, 3 times 2. Then for the entry here, we have the product of this row here by this column here. So we have 7 times 1 plus -5 times 2. And then you simplify this. You have -4 times 1 is -4 plus 3 times 2 is 6. And then 7 times 1 is 7 plus -5 times 2 is -10. Then adding those, we have -4 plus 6 is 2. 7 plus -10 is -3. So therefore, we have xy equal to is equal to 2, -3. So therefore, xy, this column matrix here, is equal to 2, -3. This then implies that x is equal to 2 and y is equal to -3. Now let us consider another example. Now to solve the system here using inverse, we will have to write first the equivalent matrix form of the system. That is of the form AX equal to B, where A is the matrix of the coefficients of the variables in the system. So that will be 1, 2, 2, 6. And then X is the column matrix containing the variables involved. So we have X, Y. And then B is the constants here. So B is the column matrix 3, 5. So that means you always have to write your system of this form so that you could easily get the equivalent matrix form of the system. And then to solve for X, you just have to use the formula A inverse times B. So let's compute for A inverse first. A inverse, or the inverse of matrix A, which is just equal to 1 over the determinant of A times the matrix formed by interchanging the diagonal entries here and then negating the entries here. So we have -2, -2. Then let's compute for the determinant of A. The determinant of matrix A is computed by multiplying the diagonal entries here. So 1 times 6 minus the product of this other the diagonal entries here. So we have 2 times 2. So we have 6 minus 4. 6 minus 4 is 2. And then let's plug it in to the formula here. Therefore, we have 1 over 2 times 6, -2, -2, 1. So multiplying a scalar to the matrix, that means you multiply each of the entries here by 1/2. Or that means also divide each by 2. That means we have 6 times 1/2 is 3. -2 times 1/2 is -1. -2 times 1/2 is -1. And 1 times 1/2 is 1/2. This is our A inverse. Now, B is the column matrix 3 and 5. Then, to get X, you just multiply this matrix here by this matrix. So again, X is equal to A inverse B, and A inverse is equal to 3, -1, -1, 1/2. And then B is the column matrix 3, 5, 3, 5. Then you multiply the matrix here. That means you get the row here, look at the row here, and multiply that by each of the entries of the column here. So we therefore have 3 times 3 plus -1 times 5. And then -1 times 3 plus 1/2 times 5. And then you simplify. So you have -3 plus 3 times 3 is 9. And then -1 times 5 is -5. So you have 9 minus 5, and then this is negative 3 plus 5 over 2. Negative 9 minus 5 is positive 4, and negative 3 plus 5 over 2 is negative 1/2. Therefore, this implies that x, which is equal to the column matrix xy, is equal to 4 negative 1/2. That means that x is equal to 4. The first entry here is 4, and y here is equal to negative 1/2.